Meaning of decimals. If we take a look at this chart, we can see that we can compare the fraction and the decimal. This rectangle has been divided into 10 equal rectangles. 6 out of 10 are shaded. That's the fraction 6/10. Our decimal is 0.6. Here we have one entire rectangle shaded. As a fraction, 1 out of 1, which is written as 1. As a decimal, we can write 1.0, or since we're writing a whole number, we usually drop the decimal point in 0 and just write 1. Here we have 1/4 of this rectangle shaded. 1/4 is the fraction, 0.25 is the decimal. If you think of money and you think of the quarter, we discovered that a quarter was 1/4 of the dollar. 1/4 of this square is also 0.25. In this picture, we have 100 squares. 73 out of 100 have been shaded. The decimal is 0.73. If we look at the bottom chart, we see that we have 2 full rectangles shaded. This represents the whole number 2. This third rectangle only has 1/8 shaded. Our fraction is 2 1/8. So 2 1/8 is equal to 2.125. The decimal point separates the whole number from the decimal part. Please remember, if you're writing a whole number, for example, if you were writing 4.0, you can drop the decimal and the 0 and just make that a 4. But if we have a decimal and a whole number part, it is separated by the decimal point. Decimals are always written in increments of 10. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, 1,000,000ths. A good hint to remember is when changing fractions into decimals, make sure to put as many places after the decimal point as there are zeros in the denominator. For example, 4/10ths equals 0.4, 8 100ths equals 0.08, and 15 1,000ths equals 0.015. Let's look at a few more examples to help you better understand. If we're looking at the proper fraction 6/10ths, since 10 has 1 0 in the denominator, we know our decimal has to have one place after the decimal point, and that is where our 6 would go. 6/10ths as a decimal is 0.6. 24 100ths. 100 has 2 zeros in the denominator. So again, we know we need 2 decimal places after the decimal point. 24 has 2 digits, so 24 over 100 is equal to 0.24. 9,000ths. 1,000 has 3 zeros, so we will need 3 places after the decimal point. We put the 9 on the end since it's 9,000ths, and we use placeholder zeros. We need 3 places for these 3 zeros. So 9 1,000ths is 0.009. 7 10,000ths. Since 10,000 has 4 zeros, we need 4 places after the decimal point. We'll put the 7 in our 10,000ths column and use placeholder zeros. So 7 10,000ths is 0.0007. 265 100,000ths. Count how many zeros. 1, 2, 3, 4, 5. We know we need 1, 2, 3, 4, 5 spaces after the decimal point. 265 must end in the 100,000ths column. We need 2 placeholder zeros so that we can say 265 100,000ths equals 0.00265. 40 millionths. There are 1, 2, 3, 4, 5, 6 zeros. We know we're going to need 1, 2, 3, 4, 5, 6 places after that decimal point. The 40 must end in the millions column. We will need 1, 2, 3, 4 placeholder zeros. So 40 millionths is written as 0.000040. 40 ends in the millionths column.
Many times when we're working with fractions, we find that we're working in many pieces of equipment, you cannot use fractions. For instance, this is a 1/2-inch bolt, and this is a 1/2-inch dowel pin. But we use what is known as a micrometer to measure it. And this 1/2-inch dowel pin measures 500, 0.500, which equals a 1/2 inch. And there's various sizes to micrometers. This measures from 0 to 1 inch, 1 inch to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and these mics even get much larger. For instance, if you want to measure something that measures 3 3/4 inches, it does not read on the mic 3 3/4. It reads 3.750. I'd like to go into a little more detail about dowel pins. And we have various dowel pins here. On the video you saw the 1/2-inch one, but they come in 3/8, 5/16, 1/4 inch, 1/8 of an inch, and even smaller and larger. And this is a catalog, industrial catalog. It has over 4,000 pages in it, and you'll find all sorts of decimals and fractions in this catalog. But notice here what it says about the dowel pins over here. Notice that it says they are oversized, 0.0002 10,000ths oversized. Let's write that number on the board here. That's 0.0002 10,000ths oversized. Now, in the machine shop trade, we'll say 2/10, but the right way to say it, it's 2 10,000ths oversized. Now, why is that? What are dowel pins used for? First of all, if you have a piece of plastic or a piece of steel that you want it perfectly lined up, you put in 2 dowel pins, and then you can put your bolts around it. And so we'll always line up because these are what we call press fit. If this is a 3/8 dowel pin, we would ream an exact 0.375 hole, and since this is oversized, when we drive that into the hole, it's tight. And that's what you want a dowel pin to be, tight. And so that's why it's oversized. And let's look at this dowel pin over here. This is a 1/4 inch one. I'm going to use this micrometer. And if you notice, this one has a readout over here, so it's easy to read. But notice over here, it's a little bit over the 0. And that's 2 10,000ths over. And you can measure easily with a mic. I've measured many times, 10,000ths over a number. This is David Guerrero, and he works here as an EDM programmer. And we want to demonstrate the meaning of this number. That's 1 10,000ths. And many times people get the idea a thickness of a hair is very, very close. And since David has a lot more hair than I do, it's obvious I don't have too much to spare. So I'm going to ask David to donate one of his hairs for science to teach you who are watching this video. David, could you give me one of your... Just one. Don't pull out too many. You got it? Another one? Try it again. You got one. Okay. Good. Now, he's so generous, he gave us two hairs. You probably can't see him on the video. Now, we're going to demonstrate over here. We have what we call a 10th indicator. And David, would you hold it over here, your hair? And each line is 1 10,000ths. That's the number we had on the whiteboard that I showed you in the beginning of this lesson. Now I'm going to go over this. Now watch what happens. It's going over the hair now. That's 2/1000ths. I've taken David's hair that we looked with that indicator, and I placed it under this video measuring microscope system. Now this microscope will go up to 325 times the diameter of the part, or whatever you're measuring. It blows it up 325 times, if you can imagine that. So, but what we have now is a lens that does 1/2 of that. And so that would be 162.5 times. And as you can see in the monitor, this is David's hair. Now I'm going to come down close on that and magnify it. Now with my crosshairs right to the edge of the hair, and here's the X over here, and I'm going to zero that out. Now this is the thickness of the hair. There's the crosshairs. Now I'm going to press the button. Now all my X's are 0. Now I'm going to move it till the crosshairs move to the opposite side of that hair. And as you can see, it's just a hair over 2,000, well, a little under it if I move it back. See, just to the edge, that's just close to 2/1000ths thick. We can take this lens here, insert this in, and that would blow it up 2 times as much. Now I'm going to show you what happens when we take a penny. We're going to take a conventional penny, and notice what's on the inside of that penny. There's a memorial, Lincoln Memorial, and watch what happens. I'll move that hair. I'll put the light coming in from the top. I'll get that penny at the focus over here. Let's just shift that penny a little bit. And you see there's an image there. Now we get closer, and that's Lincoln in Lincoln Memorial. Let's measure his head. I'll get that better in focus here. Now I'm going to line up the crosshairs, as you can see right over here. Here's the crosshair. Line up that edge, right to the edge there. Now I'm going to zero out the X. Let's measure the thickness of Lincoln's head sitting in Lincoln Memorial. It's about 4/1000ths thick, twice the thickness of your hair. So it gives you a little idea of what decimals are, and also how much precision work was done just to create a tooling to stamp that penny. And as you can see, it's actually, if you take 2 hairs and put them together, that's the thickness of the head of Lincoln on a penny. And remember, a human hair is relatively thick when it is compared to precision machining. So when you see numbers like 10,000ths and millions, they are used in the workplace.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.